Hello everyone, happy to see you here. Welcome back to my channel High Mathematics. Today we have a very interesting question from Math Olympiad. X to the power 6 equal to x minus 6 to the power 6, and we need to find our x. If you have your solution, your assumption, you can also write your solution in the comments below, and then we will check our answers. So a lot of students try to solve this question like that. They say, okay, let's apply the 6th root on both sides. So we have the 6th root right here, so we have x to the power 6 equal to, we have right here 6 roots, okay, x minus 6 to the power 6. And then of course they say, okay, we can easily cancel this 6 from here, and a lot of students might be thinking that this expression is equal to x. So in the same, we're saying in simple words, we just cancel these 6 powers. So we have x equal to x minus 6. And then a lot of students get confused because we can easily cancel this x, and a lot of students may be thinking, what does that mean? 0 equal to minus 6. And a lot of students can't solve this question at this point. I'm going to go back to this part in the end of the video. Right now I'm going to show you how can you solve this question correctly, okay? So first of all, let's write this x minus 6 to the power 6 on the left side. So let's subtract it from both sides. As a result, we have x to the power 6 minus x minus 6 from here, x minus 6 to the power 6 is equal to 0. So we change nothing, we just subtract it from both sides. Right now, let's write, instead of this x to the power 6, let's write x cubed to the power 2. We can easily do this, it's not a mistake. We can easily write it as x to the power 3 raised to the power 2, and the same thing with this one, because right here we will have x to the power 3 times 2 equal to 6, so everything is great. On the right side right here we will have the same thing. We will have x minus 6 to the power 3, and of course we need to raise this once more to the power 2 equal to 0. So it changed nothing, but right now we can easily consider our expression in terms of difference of squares. So for example, this is our a, and this expression is our b. So we have a square minus b square, and a lot of students, I hope, know this formula. We have a square minus b square. This is our identity, equal to a plus b. Yeah, we have a plus b, and times a minus b. So I really hope you understand these identities. Right now let's factor our question. Okay, we will have two parentheses. The first one with the positive sign, so x cubed plus x minus 6 to the power 3, so x minus 6 to the power 3, and the second parenthesis x cubed, but with the negative sign, minus x minus 6 to the power 3 equal to 0. So I really hope you understand this moment. We factor our question, we have two parentheses, and right now extremely important moment, because parentheses, a product like two parentheses equal to 0 when the first parenthesis is equal to 0. So let's call these parentheses as the first parentheses, or the second one equal to 0. So this one let's call it as the second parenthesis. This one is the first one, this one is the second one. So this parenthesis equal to 0 or this parenthesis equal to 0. I'm going to start with the first one. So first of all, let's solve this first parenthesis, and then I'm going to go back to this second parenthesis. As a result, we have x cubed plus x minus 6 to the power 3 is equal to 0. Let's solve first of all this expression, but let's consider it as a sum of two cubes, and I hope everyone knows this formula from school. This is like a sum of two cubes. I'm gonna write it right here. So we have a cube plus b cube. Okay, as a result, what do we have? We have a plus b, and in the second parenthesis we will have a square minus ab and plus b square. Okay, this is our formula, a cube plus b cube. Right now let's apply this formula. Right here we have difference of two cubes. As a result, we will have two parentheses. The first parenthesis x plus x minus 6, we will have first parenthesis, and in the second parenthesis we have x square minus x times x minus 6 and plus x minus 6 to the power 2. And we have right here a lot of work with the simplifying all the things. So as a result, in the first parenthesis we will have a great expression 2x minus 6. So 2x minus 6. And in the second parenthesis, let's do this. So we have x square minus, we have right here x square plus 6x plus x square. So this school identity plus x square minus 12x and plus 36 is equal to 0. So I really hope you you understand it. Right now, this x squared we can easily cancel real quick. And right now we can easily simplify it. We can easily add 6x minus 12x. So let's do this thing right now. First of all, parentheses, 2x minus 6. And the second parenthesis, we will have x squared minus 6x and plus 36. Plus 36 is equal to 0. And right now we have a great expression because we have a product of two parentheses. So it means a product of two parentheses equal to 0 when the first parenthesis is equal to 0 or the second one equal to 0. So let's split it real quick and let's write first parenthesis equal to 0, 2x minus 6 is equal to 0. As a result, we have 2x equal to 6. And from here we have x first, it's going to be our first root, x first equal to 3. So it looks like this is our first root, but don't forget about the second parenthesis. So let's find all possible roots. So as a result, we have x squared minus 6x plus 36 is equal to 0. This is a quadratic equation, okay? This is a quadratic equation, so let's write our coefficients real quick. So we have a first equal to 1. And not like a first, okay, a first, we have b equal to minus 6 and c equal to 36. I'll just forget about a first. We have a equal to 1, b equal to minus 6, and c equal to minus 36. Right now, let's plug in each of these elements into this spot. We have right here x second and third because we have already have x first. So as a result, we have minus b plus minus square root of discriminant square root of b squared minus 4ac, and we divide it by 2a. Right now let's plug in all of the things that we know to this formula. X second and third equal to minus b, so we have minus 6 minus b plus minus square root of discriminant square root of minus 6 square minus 4 times 1 and times 36. Okay, so this is our discriminant, and we divide all of the thing by 2 times 1. Right now let's simplify it, but I'm gonna start right here on the left side because I don't have enough space. So let's do this from left side to right side if you don't mind. Okay, x second and third equal to, as a result we have minus 6, we have 6, yeah, plus minus square root of, we have right here minus 6 square equal to 36, and minus 4 times 36 equal to 144, and we divide all of the thing by 2. Okay, as a result we have 6 plus minus square root of 36 minus 144 equal to minus 108. So it means that in this pair we're gonna have complex roots, but doesn't matter. Let's find this complex root. This 108 we can easily split it, but with a really great method. I recommend you to learn this method. We can easily divide it. First of all, if a value is not good for you, you can easily divide it step by step by 2. So as a result, we can divide by 2. We have 54. We can divide by 2. We have 27. We can divide by 3. We have 9. We can divide by 3. We have 3, and we can divide by 3. We have 1. So we can express this 108 as 2 times 2 and 3 times 3 times 3. So let's do this right now. On the left side right here, of course, as a result we have 6 plus minus square root of, first of all, let's write this minus 1 in the beginning, okay, minus 1, times, we can write this as 2 times 2, we can write 2 square, times 3 times 3 times 3, we can write as 3 square times 3, and that's it. Okay, we can easily write it like that, and we divide all of the thing by 2. Right now we have 6 plus minus, right here what do we have? We can easily split it. We can easily write it as square root of minus 1, so we can easily split this square root by this, square root of this minus 1, square root of this 2 square. Okay, so as a result we have square root of 2 square times square root of 3 square and times square root of 3. Yeah, we divide all of the thing by 2, and as a result, of course, we can easily cancel these 2 with this square, these 2 with this 3. Yeah, and as a result, we will have our solution. 6 plus minus. Right here we have square root of minus 1 equal to I. Yeah, or first of all, we can write 2 times 3 and times 2 times 3 times square root of 3 and times I, and we divide all of the thing by 2. Okay, really great. And the final tricky move, let's divide numerator by 2. So we can write it as 6 divided by 2, just to split our expression in terms of real part and imaginary part. So we have 6 over 2 plus minus 2 times 3 times square root of 3 times I over 2, so we can easily cancel these two from here, and right here we're gonna have 6 divided by 2 equal to 3. So as a result we have 3 plus minus 3I square root of 3. So from these parentheses we have two roots. So x second, let's consider x second with the positive sign. So 3 plus 3I square root of 3, and with the negative sign x third we have 3 minus 3I square root of 3. So this is our solution according to a first parenthesis, but don't forget about another parenthesis, because in the beginning, how can we split it? Okay, as I said before, we split our expression by two parentheses, okay, by this parenthesis right here and by this parenthesis right here. These three roots is according to first parenthesis. Right now let's solve the second one, x cubed minus x minus 6 to the power 3. So according to the second parenthesis, so let's continue. According to a second parenthesis, we will have x cubed minus x minus 6 to the power 3 is equal to 0. Right now let's solve this second parenthesis. Of course, let's consider it as difference of two cubes. As a result, we will have a cube minus b cube equal to, we have a minus b according to a formula, yeah, a minus b, and a square plus ab and plus b square. Let's, according to a formula, let's apply this formula right here, okay, in this second expression. Let's do this right now. As a result, what do we have? X minus 6. This is our first parenthesis, and in the second parenthesis we're gonna have x squared plus x times x minus 6 and plus x minus 6 square equal to 0. Let's simplify this real quick. First of all, what do we have on the left side real quick? We're gonna have x minus x and plus 6, and in the second parenthesis we will have x squared plus x squared minus 6x plus x squared minus 12x according to a formula, and plus 36 is equal to 0. And right now we have a product of two parentheses, absolutely the same principle as we had before, but moreover we can easily cancel this x from here, so as a result we have only our 6 right here, and according to another parenthesis we will have 2x squared plus x squared, we have 3x squared, so 3x squared minus 6x minus 12x, so we have minus 18x, and plus 36 is equal to 0. Right now a product equal to 0 when the first expression equal to 0, but 6 is not equal to 0, so we can easily, like in our minds, we can easily skip this 6, we can easily reject it real quick, and right now we're gonna write equation with our parentheses, because these parentheses need to be equal to 0, because 6 is not equal to 0, so the only way how can we solve it is to write an equation with these parentheses. So as a result we have 3x squared minus 18x and plus 36 is equal to 0. Right now let's divide both sides by 3. We can easily do this by 3. As a result we have x squared minus 6x and plus 12 is equal to 0. Right now, according to a method of a coefficients, we can easily write real quick our coefficients: a equal to 1, b equal to minus 6, and c equal to 12. Of course, we can easily find real quick our discriminant, and then we're gonna plug in it, okay? So b squared minus 4ac, this is our discriminant, equal to b squared minus 6 squared minus 4 times 1 and times 12. As a result, our discriminant is equal to 36 minus 48. Looks like that, yeah? 48, and our discriminant is negative, so in this part we will have a 2 complex root, but doesn't matter. Let's find it because we're interested in all possible solutions. So first of all, let's plug in this discriminant into our spot. So in the beginning we had x second and third. These are our x fourth and fifth root. We have minus b plus minus square root of discriminant and all over to a. As a result, we have minus b minus 6 plus minus square root of minus 12, and we divide it by 2 times 1. Let's simplify that. As a result, we have 6 plus minus square root of minus 12. How can how can we split it? We can easily split it as 4 times 3 and times minus 1. And according to a property, according to a square root property, we can easily write it as 6 plus minus. Right here we can write it as square root of 4 times square root of 3 and times square root of minus 1. And of course we divide all of this stuff by 2. Right now this square root of 4 equal to 2, so we have 6 plus minus 2 times square root of 3 and times square root of minus 1 equal to I. This is our imaginary unit. We divide it by 2, and our final step is to split it in terms of real part and imaginary part. So we have 6 over 2 plus minus 2 square root of 3 times I over 2. Cancel in from here, and as a result we have 3. Yeah, so our answer is 3 plus minus I square root of 3. So this is our x fourths and x fifths. So right now let's write our final answer. Let's do this. As you can see right here, we find all possible roots. So our answer to this question, so x first is equal to 3, x second and third. Right now we can see a graph, you can see these points of intersection. X second, let's write with the third one, with the plus minus. So we have 3 plus minus 3I square root of 3, and we have x fourths and fifths equal to 3 plus minus I square root of 3. So we have 5 roots, and it looks like the sixth root is gonna be 3. It looks like that, but as you can see we have all possible solution. And as I said before, right now let's check real quick. X first is equal to 3. Let's check it real quick. Okay, let's do this right now. So let's prove real quick our x first equal to 3. In the beginning, what we had x to the power 6 equal to x minus 6 to the power 6. Right now let's check it real quick. For x is equal to 3. As a result, what do we have? We have 3 to the power 6 equal to 3 minus 6 to the power 6. From here we have 3 to the power 6 equal to minus 3 to the power 6. And because of this even power, this minus 1, I can easily prove it real quick for you, because maybe someone doesn't understand. So we have 3 to the power 6 equal to, we can write it as minus 1 times 3 to the power 6. And because of this property, when we need to raise this to the power 6, we need to raise both of these expressions. We're gonna have 3 to the power 6 equal to minus 1 to the power 6 times 3 to the power 6. But minus 1 to the power 6 equal to 1 because of even power. So as a result, we have 3 to the power 6 equal to 3 to the power 6. So our root works absolutely perfectly. And right now, the final thought about this question, because in the beginning I show you, let me just rewrite it real quick. So we have x to the power 6 equal to x minus 6 to the power 6. And a lot of students, as I said before in the beginning, so let me just split this part because this is extremely important part right now. A lot of people might be thinking that we can easily cancel this 6 power. So I show you the thing in the beginning, and we can write x equal to x minus 6. It's not a good way how can we write it, because right here we have 0 equal to minus 6. And a lot of students ask me why. Because we cancel it, we can easily do this. Yeah, it's not a wrong way how can we express it. It's not a wrong thing. But in our case, when you cancel in this 6 power, don't forget about this expression can be positive and can be negative. So if you cancel in 6 power, 4th power, 2nd power, don't forget about the thing which is called absolute value. So absolute value of x equal to absolute value of x minus 6, because this expression can be positive and can be negative. And when you solve this expression, when you solve this equation, as a result, you can get x equal to 3. So from here you can easily get x equal to 3. And that's it. When you cancel in it, you look like reject complex root, because when you cancel in it, only one case when you can solve it is to find real number root. You can't find complex root. Only one way when you can find a complex root, these two complex root, is not canceling. You need to factor it. And as I said before, with the factoring, so right here let's write it as a factoring, is extremely important It's extremely important thing. So factoring is extremely important way to find complex root. Without a factoring, you can find only one x equal to 3. You can easily combine all this absolute value like positive, negative, negative, positive, and you can easily find x equal to 3. But the meaning is absolutely different. The meaning is absolutely different because I want to mention, I'm going to underline it. If you cancel it, just put absolute value. Okay, with absolute value, everything gonna be great. You can easily find one real root. But when you sit in on your exam, try to factor it. It's not that hard, and then you can easily say, okay, I solved this question completely. I found x second and third, x fourth and fifth, because in another way it's not possible that you gonna find complex root. Maybe you have your method. You can easily share your method with in the comment section. It's extremely great to see you respond down into the comment section. These like few tips. This one extremely important tips, to be honest, because a lot of students forget about it. If you cancel it, just put absolute value. But I recommend you to factor it, and then you can easily find real quick your question, and everyone will gonna be happy, your teacher, and of course you will be happy as well. Okay, so this is my solution to this question. I really hope you enjoy it. I really hope you understand it. And if this video is helpful in any way, don't forget to do like and subscribe, and that definitely helped me out now for this particular video. And thank you everyone for your support. Thank you everyone for supporting my channel. I really appreciate it. I have like more than 500 videos, 500 math questions, so it's extremely great that you support me. I really appreciate it. So wish you all the best in your life. Take care of yourself and have a great day.